Hello children, let's talk about electron affinity. Now electron affinity is the energy, right, which is released when an electron is added to an atom. An atom should be in which state? It should be in the gaseous state. It's like, children, suppose, imagine there is a person, say you are standing with a big bag, right, and your bag is heavy, full. Now in that case, if somebody offers a help and says that okay, I give you a simple white ball and you give me this heavy bag, so you are going to definitely hand over the heavy bag, right? So with that, energy released is electron affinity. Have you understood the help of it? Now see, when we move in a periodic table left to right, the electron affinity increases. And when we move top to bottom, electron affinity decreases. But there are some exceptions. Okay, so these exceptions are beryllium and magnesium. So when we move left to right, so the graph should say that from lithium, beryllium should have a higher electron affinity, but here there is dip in the electron affinity. Okay, now again when we move from boron to carbon and we come to nitrogen, right, likewise we come to phosphorus, again there is dip in the electron affinity. Okay, and then when we come from oxygen to fluorine, again fluorine has got a dip. So the trend says electron affinity should increase left to right, but this is not happening. Okay, so there is a reason. To understand this reason, children, we are going to study what are the factors that affect, right, the electron affinity. Okay, so first we talk about the noble gases. Now noble gases have got zero electron affinity. Again, understand, a bag which is completely filled and you don't need anything. So it's a room, suppose you go to a house which is fully furnished. Now you don't need anything, right? So then your affinity is zero. Okay, now when we talk about lithium to beryllium, beryllium has got 2 electrons in its outermost shell. So you can understand that beryllium has got one room. This room has got capacity of 2 electrons and both the electrons are already there. Okay, so then there is no need. So again there is a dip because they don't need any extra electron. Likewise, when we talk about nitrogen and phosphorus, they have got the s orbital filled and in the p orbital there are 3 electrons. Okay, so 3 electrons means there are 3 rooms and in each room there is one person, single person occupying, right? So because of this, again there is, they are comfortable alone, so they don't want any extra electron. So here also again there is dip in the electron affinity. Last, let's talk about fluorine. Fluorine is, understand, एक आपके पास, you have got a small bag. This bag is filled with lot of electrons. So what is happening? These electrons are repelling each other. So from outside, if one electron tries to enter, these electrons will not allow that electron to enter. So again there is a change. So the electron affinity here should be highest, right? But what is happening? Because of this, there is low electron affinity. Is this clear? So when we move top to bottom, the electron affinity should decrease. But here, in case of chlorine, imagine there is a big bag. So electron can easily enter. So therefore, chlorine has got a high electron affinity. Isn't it interesting? So electron affinity has exceptions and this is very, very important. In council, in your multiple choice question, fill in the blank or 1 mark reasoning, these questions are asked. Okay, so keep watching my videos. Thank you. Do like and subscribe the video. Thank you so much.